Welcome back. I'm going to do a quick tutorial on how to use Desmos to play around with the operations with functions. So just real quickly, I hope you saw the other video on just the basics of Desmos, but you're going to use this I think for several assignments, in fact one with operating with functions. So here's how you can do that. So if you go over here to the left again where we're going to type in our functions, I'll just show you a couple examples. So for instance, if we just type in a linear function, and it doesn't matter what kind, say here, and then let's type in another one, g of x equals, say, I don't know, x plus 3. Okay, so you got your two functions here, both graphed on the same graph here. And then on the next line, you can create whatever kind of new function you like with all the operations. So for instance, if you want to do the sum function, I'm going to call my new function just h. I know in class we called it f plus g, but here we're just going to use an abbreviating symbol to make it shorter. So h, say h of x. How do you compute the outputs of this new function? Remember, the sum function says take the outputs of each of the original and add them together. Okay, so you can see it recognizes that, and if you add these two linear functions together, you notice it produces a new linear function, which is shown here in green. Okay, so that's the result of adding the outputs of these two functions. You get this new one. Okay, so if we change it to, say, I'll show you multiplication, right? So if I erase just the sum or the addition sign there, now it's become multiplication. So my function h of x is now equal to f of x times g of x. You can see you get a whole different kind of function. It's actually a quadratic, which produces this parabola here. Okay, so multiplying these two linear functions together produces a quadratic. All right, let's do one more. The difference will also be a linear function, so that's not that interesting at the moment. So let's do the division quotient function. Zoom out. There it is. You can see that if you divide these two functions, you get this. This is actually a rational function. Okay, and you can kind of try to explore why does it look this way. You notice it has a vertical asymptote here. Why would that be? So you can play around with that and create all these kinds of graphs. The only other thing I want to show you is that you can actually restrict domains here, and this is partly where we're going to see how the domains are affected when you have functions that are defined certain ways and you try to create a new function using the operations that we've talked about. So to show you how that'll work, let me get rid of these. Let's start with this one again. And let's say you want to restrict this function's domain. So right now the domain is all real numbers. And let's say I want to restrict the domain to be, say, from -5 to 5. So let's do that. So here's my function rule. And if I want to then restrict the domain, what I'm going to do is next to that I'm going to put some curly brackets. And I'm then going to create a compound inequality that will tell me what I want x to be between. So -5 less than or equal to x, or x is greater than or equal to -5, but less than or equal to +5. Close that up. And you can see that now I have a piece of my original linear function bounded or restricted between -5 and 5. Okay. And then you can do the same thing for any other function. So if, say I create another one, g of x equals, let's do half x this time, maybe +1. And again, let's restrict the domain to perhaps x is greater than or equal to, let's do -3, but less than or equal to 7. Or anything like that. Okay, and again you get a little piece here. Okay, so there we go. And now if you try to create, say, the product of the two, so again let's call that h of x equals f of x plus, or times g of x, you see it produces a piece of a parabola. Okay, and you can find out where that goes to. And you notice that restrictions on these two domains has created a corresponding restriction on the product of the two. And you should figure out what is that new domain, and how can you always tell, given the domains of your original two functions, what will the new domain be. Alright, so that's the sort of thing you're going to want to play around with and test. You can also look at, again, if you do the division, you did a couple other interesting things. Not only is there sort of a restriction, like an interval, so there's only one piece here and one piece here, but then you can see that it's not defined in the middle here. Okay? Again, why is that? Alright, so play around with that, come up with a variety of different functions, divide them, restrict their domains in various ways, and this is the sort of thing you want to try to explore, and then try to figure out mathematically what's going on. Alright, so I hope that's helpful. Play around with it, and you'll be using this on some of your assignments. So have fun.